Assalamu alaikum students, welcome to the world of physics. Today our topic is conditions of equilibrium. For a body to be in complete equilibrium, there must be two conditions. Number one is called first condition of equilibrium, whereas the second one is called second condition of equilibrium. First of all, we are going to discuss first condition of equilibrium. According to the first condition of equilibrium, when the vector sum of all the forces acting on a body is zero, then the first condition of equilibrium is satisfied. For example, vector sum of all the forces should be equal to 0. So mathematically, if F net is the sum of the forces F1, F2, F3 up to Fn, then their sum should be equal to 0. So we can say that F net should be equal to F1 plus F2 plus F3 plus up to Fn, and all this sum should be equal to 0. For example, we are going to draw some forces over here, which we will prove that their sum is equal to 0. Like this is force F1, then this is force F2, then F3 is in this planar, F4 is in this planar, and F5 is again in first planar. This is F5. We have to add by head to tail rule all these forces, and we have to prove their resultant. Okay, now I am going to add all these forces. First of all, obviously from the origin point, I will draw the first force F1 in this way. I have drawn it. This is F1. Then on the head of F1, I will place the tail of F2. This is F2. I am going to draw F2 in this way. This is F2. Come on the first diagram. I will take force F3 and I will draw this force on the head of F2. This is F3 and I am going to draw this force like this. This is force F3. Then I have to draw F4. So this force is F4 in this way. Then I have to draw F5, and this one is F5. This is F5. In this way, I have drawn all these 5 forces in such a way that first of all I have taken force F1. On the head of F1, I have placed tail of F2. On the head of F2, I have placed tail of F3. On the head of F3, I have placed tail of F4. And on the head of F4, I have placed tail of F5. And F5's head is touching tail of F1 automatically. It means the resultant is equal to 0. For a system of coplanar forces that lie in XY plane, just like this one, then each force can be resolved into its I and j components or x and y components, and the resultant should be equal to Fr should be equal to sum of all x components. Sum of all x components means Fxi plus sum of all y components. It means sum of Fyj, where I and j are unit vectors, and this sum should again be equal to 0. If this sum is equal to 0, it means sum of all x components individually should be equal to 0, and sum of all y components individually should be also equals to 0. So in this way we can define the first condition of equilibrium, that when the vector sum of all the forces I said acting on a body is 0, then the first condition is satisfied. For example, here we have taken 5 forces, but their vector sum is equal to 0.